thank you, Professor GRAMAZIO, for being here, and welcome from me and from all the researchers and students online and in the classroom to the second session of the seminar series Positioning AI, Challenges in Architectural Design and Practice. And this seminar is part of a PhD course designed to open a conversation in our department about how technology, and in particular artificial intelligence, is changing the way we design and practice architecture. And to do so, we have invited international guests who work at the intersection of design, research, and technology. And in a moment, I'll give the floor to Professor Michele Bonino, that is the director of our department, and he will elaborate on the vision behind this initiative. But first, let me quickly introduce three key ideas that guide our approach and that we have already shared with you in a document as a provocation and a starting point for our discussion. And the first is hybrid agency. Within this school, there is a large number of researchers that study and try to describe architectural practices, not just what we design, but how we design and how those practices change over time. And the changes that we are observing today, maybe there is an audio problem. If someone can mute the audio, because maybe there is a...
Giovanni.
Prova a mutarti.
Okay.
Mutati un attimo.
No, it's good.
Now it's good. Thank you. So the change I was saying about the hybrid agency, so the changes that we are observing today, they are not just technical, but they reflect a new form of social organization of work. And we are interested in the emerging hybrid practices and agencies of machines and humans and how their role evolve with architectural practice. The second concept is politics of archives. And architects work with and generate a huge amount of data that are images, drawings, codes, models, and these archives are the infrastructure of our work. As they become digital and with AI, they could be transformed into dynamic generative infrastructures. And we want to stress the concept of politics of archives as a way to understand how AI enters and reshapes the design processes, redefining the very condition of design possibility. And the third concept is politics of technology. AI not just transform tools, but also impact authorship, labor division, and distribution of responsibilities in design. And we see this as a part of a broader politics of technology, which is why we are interested in navigating the socio-technical dimensions of tools, not simply as theoretical or critical exercises. So yesterday, we had the opening seminar with philosophers and computer scientists for a broader view of artificial intelligence and technologies in changing architectural practice. And the recording is available on YouTube at the link below. And today's guest is Fabio GRAMAZIO, who is co-founder of GRAMAZIO & Kohler Architects and leader of the world's first architectural robotic lab at ETH Zurich. And his work merges advanced architectural design and additive fabrication processes through the customized use of industrial robots. And now it's my pleasure to give the floor to Michele Bonino, that is the director of our department.
Thank you, Federica. So very shortly, first of all, let me say that I'm very happy to welcome Professor GRAMAZIO to meet you for the first time, even if online. It's a real pleasure for us as the first lecture of this event, of this series after the seminar we had yesterday. And more on the topic, I would like to point out a couple of issues. One is let me call it the starting point of a large transformation that our department is experiencing. That this started with an initiative a few years ago, like 5, 6 years ago, where some of our professors with students, including Federica, was a student at that time, visited your robotic fabrication lab as a part of a European tour to see some lab and workshops in order to get inspired for our extensions. Now we are almost at the end of this process. In a couple of years, the new part of our school will be inaugurated in a very nice structure designed by Pierluigi Nervi, just a few hundred meters away from our present venue. And so a part of this inspiration that is bringing us to extend and to have new laboratories also comes from this very first exploration to your lab. So this is very interesting. And also more talking about the PhD course that Federica and other PhD students organized, is that positioning AI is quite relevant for us right now, because we started to do since 1 year, 1 year and a half, some steps about including AI seriously in our teaching and in our research. So now is the time, after we did these steps that are about opening 3 different courses, one in the bachelor, one in the master, and this in the PhD, and also launching a special position for a young scholar that will be selected in the next weeks in order to bring specific expertise on AI in the department. So now that we have these initial steps, we need exactly that to find a position in the overall discussion on AI and all related topics. So this is why it's very important to have you, Professor Gramazio, to this lecture. And so welcome, and I will enjoy your speech. Thank you very much.
Thank you for the kind introduction. Thank you, everybody, for the invitation. It's a pleasure. It's a pity that I cannot travel. It's the wrong moment in the year.
But we will organize another moment.
We
for
try
you
to
come
find an occasion. It wouldn't be far away at all, but right now it's it's so packed with the term and the teaching and everything. But I'm positive that we'll find another moment to meet in person. Maybe let me start sharing the screen so we're sure that this works. I'm not used to. If I just want to content only screen, here we go. Yeah.
Great,
Okay.
we see it.
You see it perfectly.
Yes.
Let me, yeah. Okay, fine. When I realized what this was probably 2 days ago, when I read the paper I got from you, I realized that your seminar is about artificial intelligence in architecture, which is a thing that for all of us, for the whole community, is extremely important. But at the same time, I realized that the work that we have been done in the last 20 years is not related directly to artificial intelligence. And as many others, we are in the last few years, since this re-emergence of artificial intelligence as a reality, which has, I would say, at least 2 big precedents. The first one in the 60s, and then a second one in the 80s, when we felt not just architects, general, the scientific community or society felt to be almost there, with all the implication this has. And architects were always very sharp in interpreting, these moments, in incorporating them in their work. I think of the cybernetic movement that starts, not even in a computational environment. It's more about, describing nature, describing systems, describing the human intelligence, with the feedback systems, and then is adopted very quickly by architects that start to imagine what this would mean to design. And then this goes in several different directions. You have the British Cedric Price that take it more on a playful level and develop projects like the Fun Palace, where the architecture becomes a machine, a system that communicates with its users and that controls its users. So all this different, also dystopian, components are already there. While other people like Negroponte in the US, financed by the Pentagon, is more interested in this machine as an assistant to the architect. Also with a lot of implication of what it means being an assistant to the architect. And other people, Marvin Minsky, very serious scientist, at the forefront of this stuff, not from an architectural point of view, but from a point of view serious science, is convinced that it will take another few years to have artificial intelligence as intelligent as an average American. That is probably 68, 69 when he advises Kubrick on, this epic movie, A Space Odyssey, 2001, A Space Odyssey. And then everything collapses in 3, 4, 5 years. 73 oil crisis. There is no progress in artificial intelligence. It's clearly, it's not a matter of computing power and so on. It's just that probably the symbolic approach they chose back then, and trying to replicate, to model the brain, the human brain, as it would be a machine isolated from an environment, is doomed to fail. And there is no internet there. There is no big data. There is nothing. And then you don't hear anything anymore for probably 15 years. And in the 80s, the discussion restarts and there is breakthroughs, but from a completely different direction. There are a few people that claim and understand, or do experiments, impressive experiments, just saying that our intelligence, the very notion of intelligence, needs a body, needs an embodiment, needs an environment to exist. And this is the second spring of artificial intelligence, where I think the experiments of Professor Pfeiffer, for example, at University of Zurich, among many others, they do very simple devices that are able to, or the observation of, birds groups, this coordination between entities that are not intelligent per se, but develop, and then there at this point, questioning what intelligence is becomes the question. And we start to realize that it's not so simple even to define what intelligence means, and then the whole thing disappears again, not because there is no computing power, but because the concepts were, and then, we'd say 2 years ago, suddenly this breakthrough with ChatGPT. And since then, everybody is, I would say, including us, disoriented sort of, because it's clear that, again, a big thing is happening, but it's not clear yet what this means to our profession. And I would say the only thing that is clear to me is, and probably this is already enough, is that what is gonna happen, it's in a continuity with what has already happened. We always, if you are just 5 minutes, before or after a big change, we have a hard time to read things. We need a distance to interpret phenomena. But again, there is a big change. It's like, the the last time I would say this is comparable with the internet, for example, for our mobile telephones, for our understanding of the city, of space, of distance, of community. Or it's comparable with the introduction of computers, not mainframe computers, but just computers into society, available computers to architecture too. So it's these big changes, and they don't change just the way we draft architecture, for example. So you could say, okay, the computer is just used to draw plans. It's true. A lot of 80% of the community until now has misunderstood the computer to be a machine that allows us to do, to draw architecture, but actually it's much, much more than that. And the question that open in front of us are huge. So long story short, I was then thinking, okay, what I'm gonna show, because just to speculate here on what the future will bring us is difficult. There are people that build their profession upon telling you what will be in 10 years, 20 years, and futurology, I think it's called, the discipline, but it's not what we do. So I will now in the next 45 minutes give you just a view back on what we have done starting in around 2000. And this will not be directly about artificial intelligence, but it is indirectly about what technology, what this digital condition does to architecture, or should mean to architecture. And a lot of these things are, and we'll see, already questioning many of the categories, because we in our work never were interested in drawing architecture faster, in optimizing anything. We're always interested in where does the digital, let's say, domain that that goes beyond the computer, that allows us to do calculation, the digital culture, where does it meet our material culture of architecture, and how does it change it from a perspective of design only. Everything else then happens automatically, but the perspective of design is the most important one. And I think if I give you this overview on the work that is always also a lot about our thinking, then for the discussion that follow, we can try to discuss what these things mean to the moment where we are right now. Because I would say this is comparable to how we felt, Matthias and myself, 20, 25 years ago when we started this journey. So the feeling that nothing would be again, like it was yesterday, that we would have an infinite, potential space in front of us to rethink, think, and also to play with things. So. In this sense, I will talk about digital materiality in architecture. This is probably the most, the simplest way to define our work. It's describing I would say, a condition that nowadays I read many articles in architecture just use the term digital materiality as it would be, established in some sort or have a meaning, make sense. But when we came up with this thing, it was 2005-06 for a publication we did with an early work with Lars Müller. It was really the wish to bring together two things that, at least in architecture, were not belonging together. And this was a lot about the 20 years before this moment. So when we were socialized and then studied architecture, so the 80s and then the early 90s, when these two domains, programming And it's probably because of the backlash at the end of the 60s, you know, when all the discussion on cybernetic or computing was sort of abandoned, and then in the 90s came up with the discussion on geometry. Think of Greg Lynn, the blob, you know, all these things, very interesting things in which we have been socialized. You know, these were things, although we studied at ETH Zurich, a very conservative school that had computer, but at the same time, I drew my diploma in '95, my thesis by hand, you know, with ink. So this contrast, this dichotomy, and we both felt that these two, you know, discourses and worlds, the digital in architecture and the profession of building architecture with physical material and creative spacing in which you would live, you know, illuminated by real light, were just not communicating. They were both there, but there were no bridges. And with these terms, it was completely artificial, it was irritating, it was sort of a provocation. We were claiming that these things were, you know, linked together so tightly that you should think them in parallel, you know, not sequentially, and not one in the service of the other one. You know, the digital to draw or to design the architecture, but these things would be the same. Okay, this is was a bit long preamble to explain why I will not talk directly about the artificial intelligence, but only indirectly, and why I talk about things that are 25 years old. You know, feels like a bit dinosaur. You know, if it's your stuff, 25 years is not a long time, but it's still, in a historic perspective, it's a long time. To frame this time, around 2000, I would like to show you a project. This is not a research project. This was an early office project that was done, you know, as many young practice when you have a lot of time. But it's a privilege, by the way. Little work and a lot of time to think. And then you realize many years later it is still around. You know, it's sort of naive in a nice way, but it's also very important because it defines you. What we did here was to propose and to also to design and realize a table design that would be designed on a mobile phone. From today's perspective, this is not so maybe uncommon because we have thousands of apps, but back then the smartphone didn't exist and the app as a concept didn't exist. You know, and what we wanted to ask or to, you know, share as a question was following: how does technology, you know, technology not as a, you know, we could have done this project on a PC with AutoCAD, you know, but then we would have proposed, you know, a design, a professional situation. Here we're saying, okay, let's take a phone and let's write an interface, design interface that is super simple, super reduced, and then let's have technology, digital fabrication technology. You know, just take this data and translate it in an object, a real, you know, object in the real world at the highest possible resolution, beautiful material, timber, you know, very, very, you know, sensual materiality, without any operation, without any architectural decision taken in between. You know. So how to connect direct data to the physical world? Question one. And the second one is what happens, for example, to authorship, or what does authorship at all mean in such a context? You know, not just authorship in terms that this is my design, but also where is the design intelligence? Because the design intelligence here got encapsulated in this little bit, you know, tiny software that nowadays you would call an app, that was written by us and downloaded onto this. You could say this one is the first smartphone before the term the world even exists, but it's a smartphone from what it did, you know, the capacity. And we just deliver a design system. Here you see how it worked. It's super reduced. It's simple. You have a surface. You apply points on the surface. You deform the surface by apply physical pressure on the joystick here. So these things didn't have a touch screen. And then by deforming the thing, you create holes in the surface. And let me move to the next one. Yeah, there is somebody that has the mic on. Let me move here to the here. Okay. Now what we see here is the parameters describing this sort of complex but also provoking and absurd piece of furniture. So a table with holes doesn't make so much sense, you know, but it's beautiful, it's sensual, it's real, and can be described by just a few parameters which are human readable. You know, it's authorship, it's a dimension, and then it's just the position of these points plus the force, the magnitude on these points. And then you translate this knowing the algorithm, so knowing how the process works, having, I mean, literally the software. This was not in the cloud, this was in our office, a machine that was getting these parameters. And then you translate this in a, you know, a NURB surface, which is a mathematical definition of a geometry. And then through a next translation that is also just, you know, straightforward, you produce a G-code, so CNC machine data for a mill, and then you let this mill run onto a board of timber, and then you create this object that is at the same time questioning its function, but also extremely beautiful. You know, it's seducing, and it's you know, just done by a lay person that has no education in design whatsoever, with on a mobile phone with a display with just a few pixels. And you see these objects. And you know, I will end this project on this because this is an emblematic picture. This is, I mean, the table was produced as an art project in a series of 10, of course, expensive and very, you know, beautifully crafted. But probably the most important or interesting part of it is the hundreds of tables that were never ordered. No, this is just a small cutouts of these things. And here you see that, you know, so a few things. I'll comment on this. First, you see that they all look more or less the same. So there is a common, you know, design route that is given to them, that comes from us, and that doesn't really allow the co-author. So this participation, you know, has a certain boundary condition. You know, and this is a positive message, because back then the question on what happens if you give the algorithm or the parameters or the system too much freedom was a very, you know, virulent one, because a part of the community was saying, then if you do this, anything goes. You lose completely control on what, you know, design is. This shows the contrary. You know, shows that indeed you can open up these systems, include others, but still have a great deal of control on the thing. No. This is the first thing. But the second thing is also, if you look at them carefully, you will find out that, you know, some are beautiful or elegant, some work, and some other don't, you know. And it starts with the decision to make a hole in your table, so to undermine the function of the table for sake of whatever, you know, beauty or provocation, you know, we just offer the tools to do it, but we don't give you any instruction to do it. You know, there are some that don't have any hole in here, you know. So the problematic of opening up to others, and here is just one other, you know, author. But in architecture, you know, the stuff we do, the cities we do, there are millions of users, you know, being concerned by it. And the question is, where is this, you know, interface between our agency, you know, to define things? Where are we? Do we need to include others in a design process, you know, and where do we need to define the, let's say, the boundary condition of this interaction in a very carefully way, you know. And this now is 25 years old. It's only about parametric design and digital fabrication. Looks old, but the questions stay the same. You know, if you have ChatGPT, what do we do with ChatGPT, you know, or with other tools that are extremely powerful, you know? Here, the power was, I click a few times on a mobile phone, I pay $10,000 or euros, and then I get the table delivered, you know, cool. What did I do with it? You know, and the same question come up now, probably on a complete different level of magnitude. Okay. After this first project that was done not in a academic context, but very, very formative for us, still very important, I now switched to academia. In the office, we went on doing architectural projects, but everything that was really speculative and research oriented was then done at ETH from 2005 on. And the first action we did here was to buy this machine, the machine that you see in this picture. We bought the machine and we hired one person. This is the person sitting on the robot. It's still with us, just 20 years older. And what you see on the picture is not the way you use a robot. This is an artist's image for a publication. But I like to show the robot in this artist picture because it clearly explains what we look for, or what we looked for and still look for. This is that there is a mutual relationship between the human and the machine, clearly. The machine alone is not of interest. This is here. It's symbolized by the fact that the person sits on the machine, is you know, at the mercy of the machine while controlling the machine with this you know, programming tablet. And these two, I think it's a condition that we can you know, consider to be valid now. You know. So this artificial intelligence, does it has a value on its own? I'm not even thinking of, you know, fearing to lose control or to be dominated, you know, by or you know, by artificial intelligence or by robots. I'm just thinking in the profession of the architect, you know, with all the you know, the dependencies that have been already described in the last 80 years, probably. Of thinking about the relationship between the human and the machine in architecture, you know, what does it mean? Is it a companion? Is it just a tool? You know, and we are craft people, have a tool, become more powerful, or is it more than that? You know, do we consider us to be different but at the same eye level with a machine, or is there a clear relationship of hierarchy? You know, this image here says actually no, you know, we're just different, but we need each other. The machine needs us as much as we need the machine. You know? So these are open questions, but we started with this because we got an assistant professorship, and we had the budget to buy something. And instead of buying a CNC router or a laser cutter or something else, let's buy this machine because it's a champion of industrialization. But at the same time, it's and this has a lot of advantages to architecture. It's already back then, it was very cheap, it was very big, it was very strong, it was very robust, you know, designed not to fail. Then it's anthropomorphic. It's called robot, you know, it's the only machine called robot. You know, robot comes from fiction, you know, not from technology, the term robot. But the only machine that got this name is this industrial robot. I mean, of course, now we have humanoid robots and this stuff, but back then this was their robot. You know, there was no other robot except in movies and in literature. And so this thing was extremely attractive to us. And then the next question was what we are going to do first. And the decision was to go for the brick. The brick because it's just the oldest standardized, industrialized material building block of architecture. And it's an element that has been designed and optimized over thousands of years to be, you know, used or built with by humans. So if you think of why a brick has the dimension it has, it's because you need to be able to lift it with one hand, you know, not with two hands, because if you lift it with two hands, then you need a third hand for the tool, you know, to put the mortar. So it has this intrinsic intelligence that is a result of a cultural evolution. And you say, what if you expose this, you know, key element of construction history, of construction culture to this new machine that also is just the possibility to put something in space at a certain position and eventually do an additional operation. But before doing an operation, I just can reach a point in space. So the brick wall, and then of course, if you start to think along these lines, for us it was a proof of concept, a possibility to produce a proof of concept. Then you have to think of notations. So how do you describe this physical output? And then things get interesting because it's about communication. So we can communicate among humans. And if I want to communicate with other humans, probably I choose the notation you see here, the drawing. I mean, not non-professional. You know, if I have a drawing, nowadays I would do a rendering, but when I studied, you know, if you want to show a brick wall on a drawing, you had to draw it this way. You know, so somebody else says, okay, this is a brick wall. Very cool. You know, in building construction context, nobody draws brick walls to tell somebody else to build a brick wall. It's completely dysfunctional. It's too much work, and it's prone to misunderstandings. And this is where culture comes in as a category. We have, you know, learned to create abstractions and to name them. And a concept like a brick bond, you know, is something that is both the literal description of the steps you need to perform to build, but it's also something that if I say a stretcher bond, everybody from now the profession, being an architect or a mason, immediately sees in front of your, you know, internal eyes, you see this, what you see on the left. No, without the need of any drawing. And here we are in parametrics. You know, so we compress something down to the rule set, and this allows us to specify the length, the height, and the module. And then you just need the position. If you go to a building site, you know, and look at what people do, for example, in the evening when everybody has left. You know, the last thing they do is to measure in a line, and then they take you know, a spray, for example, and spray a line or 2 points for the people the next morning to build something there. You know, so there is this compression of data to a minimal set of information, which is you know, now close to what we have seen with the table before. But this is the reality of how things are built. Now, if you want to have a robot doing the same, then you need to extend this notation, because a robot, you know, maybe ChatGPT could do something with a stretcher bond. I haven't tried, by the way, but probably if you would ask ChatGPT, do me a stretcher bond, GPT would be, and I don't use now the term intelligence, but would be able to, you know, find out statistically that the stretcher bond, you know, has these rules, and would able probably to give me a Python code to do it. But back then, ChatGPT didn't exist, large language model didn't exist. So the only way to explain to a robot or a computer driving a robot how to do this would be to program. And this is where the second beautiful thing comes into place here on this example. Next to the brick, that is this fundamental building block of architecture, is that a bond is nothing else than 2 nested loops. For everybody that knows a little bit about programming, this is perfectly logic. So one loop is making sure that the next brick is always placed next to the previous one until a certain condition is met. For example, you know, the length is achieved, or there is something, an obstacle, a wall. I can tell, you know, the algorithm, but also the mason in several ways. I can say, do the wall from here, and the brick wall from here to the other wall. So this end condition is clear. And then the second loop is just the development in height. You know, when one row is done, then you start over again, but you start over one brick higher, and then you move your starting position by half a brick plus the gap, and this gives this, that is not a decoration, it's not a picture, but it's a constructive, you know, needed compound. Otherwise, this thing wouldn't hold up. Okay, so far so good, but it's boring because we just achieved the same result. So we are doing automation. This is what automation is about. We observe what the human can do, and then we do it with better tools, and speculate that, for example, a robot could do this 24/7. Doesn't need, you know, food, doesn't need to drink, and cannot strike, and you know, is not politically active. No, this is what the 20th century has been about with machines. But what interests us is something else. I'll show you now where this little difference comes into play. The difference is what you see on the right side in the algorithm. It's the last 2 lines in this very banal, you know, nested loop. Because here a human, and this is the student, this is true story, you know, on the left, added rotations. And this rotation were not added based on a formal, you know, theoretical whatever wish, but were based on physical experimentation with bricks, finding out how could such a bond, you know, be manipulated. So where are the degrees of freedom? What can I do? And he decided for a rotation based on his experience and observation on the real model, and added this into the algorithms. Now you don't have to understand how the, you know, the rotation is calculated. This can be done in 1,000 different ways, but the important thing is the calculation is added, and that now something fundamental happens. What before was a pure, nice, beautiful rule that would allow a human to perform the action, would allow to be communicated with just one concept, stretcher bond, and would allow the human to perform this operation in a very efficient and robust way, now becomes something completely different, because the output of this same algorithm with this rotation added creates a list of data. For each single brick, there is one rotation. This is a small data. This is so small that you cannot read it. This is on purpose. Information is there, but now it's not human compatible anymore, because if somebody wants to go through this data and for each brick, instead of just laying it to the last one, wants to measure in a rotation, then a very simple thing happens. The time needed to build the same wall just doesn't double, but probably becomes 10, 20, 100 times longer. And this directly in a linear way, has an effect on the price. And since architecture is not art, this has never been done so far. But with a robot or any other machine, but the robot here is key. The robot doesn't expect anything else than these numbers, because the only thing the robot does, except a bit of inverse kinematics and so on, but basically it's about numbers being interpreted, being converted in signals for motors that rotate to a specific position. That, the sum of this rotation bring the hand of the robot in a certain place. While the robot and the computer driving the robot doesn't understand what the bond is in any way. This allows us to directly connect the physical human understanding of the world, the material world, with all of its complexities, through design, with a machining act of building. No? Good. And the result is something like this, for example. No? And this is say beautiful, of course, but for us this was a sort of a key moment when we observed these artifacts back in 2005-06, because we realized that here these two domains, the digital, so the computational in architecture, meet the physical in a way that really changes the game. So this is not the computer to draw plans to be faster. It's not about doing the same thing. It's about doing something with the same efficiency that was not accessible before. So it's not optimization. Here you have to make an aesthetic, cultural design decision, if you like it or not, But it's clearly something else, because it's not, of course, now I'm showing you an image of it. This is a bit difficult, because what you see here doesn't exist in reality. If you move by 10 centimeters, you will see something else. So architecture is not graphic design. This we know already, as architects. But here it becomes even more complex, because you have two let's say, two things that happen. One is, how do I design this? Really pragmatically, how do I organize this very simple bricks in space? It's no magic, it's just a rotation, But each rotation depends on the last one and on the next one and all others. So it's not a thing that I can model. I cannot draw it, I need computational tools to do it. I would say the organizational logic back then was not new, because we were experimenting with drawing or graphic in computer since the 60s in art. I would say the 90s have introduced algorithmic design into graphic design a lot. Think of Photoshop, of the possibility to use data, to manipulate data, to apply filters, to apply algorithms to these things. But until here, this very moment, it was always two-dimensional. So it was eventually applied to architecture, you know, in the same way you apply a tattoo to your body. No, it's something applied on the skin. And you know, this for us, this moment was also a critique that then in other work became very, very important for us to this superficial, you know, relationship to images. That was in the 90s everywhere, you know, big important architects like Herzog de Meuron introduced it, you know, on glass, on concrete, you know, and with artists, without artists, all these things. But we felt that, you know, these things were sort of shallow, you know, because it were like tattoos. They were not really part of the architecture. They were not volumetric. They were not, you know, interacting with light. They were not creating transparency. They were not creating tension, and they were just flat. You could change the point of view, they would not change. You know, architecture is an art that always only lives, you know, in the movement and in your perception. And the perception is more complex than a postcard, you know, of architecture. Good. So this was a revealing moment for us. And the other was, of course, the materiality. You know, everything we knew from computer until then was always, again, not sensual. You know, now with all the rendering techniques, but it's still not there. A real, you know, material with real light is a complete different dimension. You know, it's a thing that speaks to the body. Good. This is the logic that then in the next years we went on experimenting with. And what we did was to, you know, there are two vectors. One is the vector of the material. What you see here is a project that we realized just a few months after having done this first proof of concepts. Winery Gantenbein with friends, Berthe Platzes architects, that had a commission to build this thing. And then they asked us to do the facades for it. And here's the design paradigm we applied. We took their project because it was for us like a ready-made, it was already done, and applied, you know, filled this basket with spheres, and then we transferred the visual information of this artificial content, virtual content, to the rotation of the brick, and ended up with this you know, first physical implementation at the larger scale of this very simple concept of the rotation. So we were able to test the architectural implication of this process. Here you see a movie of the fabrication. So it's extremely simple, straightforward. Back then we were talking about 3D printing at the scale of architecture. Only the processes that really require this degree of information, the applying of the adhesive and the application of the adhesive and then the positioning of the brick are automated. Everything else stays just prefabrication done by human. For example, here the feeding of the machine. This is also the quality control to see if the bricks are good. And with this process, we ended up in probably 1 month of production to do about 300 square meters of facades, and then were installed in this winery. I was saying before, the vectors we used on this very simple paradigm to extend the research were the material. Is where, you know, we started with brick, but we, you know, explored many materials. I'll show you in the next projects some examples. And the other vector we explored was, where is the machine really, you know, involved in the building process, and So what is the human doing? And this very simple distribution of labor that you have seen now in this first experiment, the robot does the pick and place, and the human does the rest, has then be also reconsidered, and in a more complex way, because those also has a lot of implication on the social boundaries of these things. So what is the future of not only design but also of work? Here are just a few images to show you what happens. This building doesn't exist. It exists only in this way. You see it on the picture, but if the light source moves, if you go closer or farther away, this completely changes. So it's only about perception. It's about light and material. So the foundations of architecture. Good. Very quickly, a second project. This is way younger. This is 2019. It's in Greece. It's again a winery. It looks similar, but it's the opposite. This is not designed by Swiss architects. This is designed by a Greek engineer. And then abandoned, as many of these things in the landscape, bought by actually an engineer, a mechanical engineer that decided to produce wine. He got bored. He was working for Shell all his career, and then he was fed up with drilling for oil, and started to produce wine. And he attracted our attention because basically he asked us to complete this incomplete brutalist building in a beautiful landscape near Thessaloniki. And for us, it was clear here that we would not be able, but also not willing to use a robot to do this. So we didn't want to replicate Gantenbein in a different socioeconomic context, 12 years later. So we decided to leverage on so first to reintroduce mortar, and then to leverage on craft, and to have these big elements, 5 by 5 meters, completing the structure, built by local masons that would be instructed by augmented reality, by just an interface that would allow the human to deal with complex data and to leverage on the craft. Because what you see here, this is a thing a machine cannot do. Wasn't able to do it, 2006 for sure, but also 2019. This would have been extremely complex to tell a machine to use mortar at this degree of perfection. And what the human is not able to do is the last 5 millimeters or 12 millimeters or maybe 20 millimeters worst case. But we have a great deal of intelligence, of understanding for the three-dimensional space if we are trained craft people. So we can place the parts where they should go, and then the technical system that you see here with these arrows tell the human where to, position it at the end. And this is, again, what is this? Is this a companion? Is this a partner? Is this just a tool? You could argue that this is nothing else than the string the mason has. If a string wants to do a straight wall, just puts a string, between two things, and then aligns the bricks on this string, because this thing we are very good at. And here the string is given by the technical system. I'll show you quickly this movie that shows this process. Maybe, yeah, here. This was a PhD work of a student, so it was very prototypical. All the hardware was custom built, but I would say now, a few years later, this could be done with industry standard, tools pretty easily. You see here, she films, the assistant films the real scene, and then the images are overlaid with the model, and this information is given to the mason on a screen. So it's very It's very simple. And the interesting thing here was for us to find out how this human-machine collaboration that now is less clear, you know, with the robot, the technology is very visible. It's also threatening because the robot is the symbol for industrialization, for you, if you think it in a Marxist dialectic, you know, it's the capital that stands in front of you, you know, the threat to your you know, job. Here it's not so clear anymore because you're there, you're doing the job, you're a craft person, you are you know, augmented by this technological tool that gives you data. So questions like, do you feel enslaved, controlled by the tool, or do you feel augmented? Are you, you know, proud of your augmented craft? These were questions that we wanted to investigate. An interesting thing here, beyond the fact that that we tested it on 4 Masons that all were able very quickly to understand the logic of the tool. The interesting thing is, at least in this setup, I don't want to generalize, but in this setup, all of them were at the end very proud. So this relation with technology has been very positive and sort of you know, connecting to probably more the concept of the tool that they were already, you know, used to think as a partner, not as a threat or as an enemy, you know, to their things. And you start to sense that if I talk about tools and things, I think, you know, we architects are just craft people, you know, and we use certain tools. Sometimes we are aware, sometimes we are not aware, you know, sometimes the tools influence us, we become victims of the tools. Sometimes we become master of the tools because maybe we create them by ourselves. You know, we have the agency not to create just the architects, but also the tools. Yeah. Now this I go very, very quickly because I want to show you a last project. This is the institute building that then we did with the similar process, just on another scale and with timber instead of bricks. 2015, 16. You see here just trusses and fully computational design, 50,000 different parts, 1 million nails. So here even more clearly beyond the you know, possibility of any human, doesn't matter what CAD system you have, without, you know, a computational design logic, there's nothing to do here, just sake of the complexity of quantities. This was the optimization, so it was about finding the right place to put all this crazy amount of nails. Yeah, but I want to show you the movie here. The process itself, once you have organized your design system and programmed it, is again very basic. It's just a slightly bigger robot that picks slat material, cuts it at 2 ends, and then lays it on a bigger base, and sequentially creates what we, you know, at the end have as a truss. And the principle is again the same. The geometrical position, as long as it's feasible. It's feasible, I mean, in the domain, in the reach of the machine, you know, and feasible in terms of you know, constructive logic. So the collision, gravity, all these things, or, you know, just geometry. Is there enough place to put the needed amount of nails into a connection? Yes, no. Then it's a very, very simple process. Here you see the finished one that then gets assembled to its final prefabrication level with all the subsystems. And here you see what is now the fundamental, you know, thing is, in order to realize something like this, we have to think differently about architecture. You know, so architecture is not a result of a drawing. You know, we have an idea, we draw it, and somebody else builds it. but we have to really consider the whole process, including, in this specific case, structural analysis, because if you build a, you know, a 15-meter truss without structural, you know, consideration, you go nowhere. Then the fabrication. Here I mean reachability. I mean this, you know, it's fine if you want to put, if you need to put 20 nails, it's cool to know it, but you also have to be sure that there is a space to put them, otherwise it's not big. And here you could then add other steps, you know, that are part of the design process. But the most important thing is that you need to be able to fed this information or this feedback into the design itself. And if you are designers, you know that this is a very normal process. You always, if you draw whatever, something, then you ask, you know, a craft person or your, you know, mason, could you do this? And then he tells you yes, but maybe change this. This is an iteration. Now the difference here is we're talking about thousands or 100,000 or millions of parts. And with one iteration, we don't go nowhere. We need potentially millions of iterations, you know. So without computation, this is not feasible. This is then the result. Okay. I think these were these two projects probably were showing the architectural logic of it with traditional architectural material, or that architectural implication with traditional architectural material. Now I show you quickly one or two projects that go beyond this, where we look at material that have also the potential to redefine the process themselves, because they have a behavior or they have an intelligence of you know, of their own, or they have yeah. Here you see we imagined a machine that shoots material. So it's a counter statement to 3D printing. 3D printing has a big machine and a small building. Here we said a small machine and a big building. Then we need to be able to bring the material in a you know, more in an easier way. You have ballistic curve physics of them. We all know it from high school, but we also know that it doesn't work because it's you know, depending on too many other factors. Here we are, you know, this is cybernetic, the feedback. So we have a scanner that looks at where a part landed and then corrects the initial position of the throwing mechanism. And this is probably the foundation of you know, military science is artillery, and artillery is about feedback mechanism. Okay, then the material. Material is not unimportant, because if you throw brick, they just break. And also throwing timber is not very productive. So you need something like clay in this case that can, you know, be extruded or portioned in, you know, with a machine here, in just in this case cylinders, can be thrown, but most important of all, can, when it lands, deform. Now this deformation is a very interesting thing, because now the fact that it deforms allows this wall to be built. Because one thing is to make sure with the feedback mechanism and the redirection correction of the throwing mechanism that this part lands. But then if you have achieved this, you need to be able to create a bond that has a capacity to self-assemble to a certain extent. So the part finds its position, deforms according to the neighbors. No? And maybe I can show you here, you know, close up. You know, look at this. This is extremely beautiful. And why is it beautiful? Because we would never design it. Because it's an expression, direct expression of, you know, the fabrication process. And you can read the dynamic, you can read the forces involved, you can read from in what sequence these parts met, you know, the architecture, the material that was already there, because this was then, you know, sort of informing their deformation. Yeah. Yeah. So this is, and this then we did several other experiments, more control like here with this one, and less control with this. This is so this movie. This is an aggregation process where we, you know, just went closer, but still accelerate the material, you know, in order to profit from the self-assembly potential the material itself has. You know, other in the disciplines speak of you know, physical computing to describe something like this. It's something that goes beyond what you could simulate with machine learning in any way. You know, it's just there. It's just there, and you just need to make use of it. Okay. This then was also done at a larger scale with a larger machine. Yeah. And of course, there you have less control than in the experiments we have seen before, because the machine is, you know, a bit trembling. But the results are also very beautiful, you know. So the trace of the machine that builds it is imprinted in the physicality of the product itself. Okay. And now I go one step further, because that we can build with clay is known to everybody. You know, the original, the origin, the genesis of the brick is the clay portion that is added one on top of each other by humans, and only then later becomes burned. And then people, you know, find out that if you give them a certain shape, you can build walls with it. But it starts with there. This is another mechanism. This is building with gravel, or building with rigid bodies that don't have a predefined clear geometry. Making use of a physical phenomenon that is called jamming. There is a whole branch of science. There is a community, the physicists that look into jamming. It's a very complex phenomenon and fascinating. We didn't fully understand it, but as architects, we were fascinated. Basically, what jamming is tells you that if you have a certain amount of rigid bodies, and if those rigid bodies are constrained by geometry or force in a specific way, they reach a condition where they are jammed. This is on the left, so they cannot move anymore. You know, as soon as you remove this boundary condition, for example, release the load, then they liquefy, you know. And this is very much depending on the geometry of the parts. Here, cornflakes work very well. Imagine doing it with spheres. You'll never be successful doing this. But what interested us was doing it with gravel, because gravel is available everywhere. It's the cheapest, most sustainable material you could ever imagine. To do this radical experiment, it was about creating building structures that would be 100% reversible. And to do this, we first explored potential you know, materials to aggregate with the gravel. We did tons of experiments, many failures, but the one on the right now you see here with this string in the material, we started to be successful. So this thing started to you know, to stay in place and to be robust and stable. We scaled this up and up, and you know, eventually decided here you see the material system, gravel and just a string. And this is not a high performance, expensive, whatever. This is the cheapest string you can buy at you know, at in every store. It's recycled textiles, because it's not about large forces. Here you see how this material then behaves. It's very strange. by combining this gravel with the string that does nothing else than to introduce a boundary from the interior. So basically, every stone sort of creates a friction with a string somewhere, and the string holds the stone, the gravel back from falling out. If it would fall out, it would create a chain reaction, and the whole thing would collapse. And you have seen also in the other experiment, it's almost elastic. It's pretty magic. Then we scaled this up, looked at what aspect ratio we could realize, and at a certain point, this is a way our research is often working. We often start from invitation to exhibition or stuff like this, and then we do an installation. And if the installation thing is successful, we write the grant proposal and then look into the science, into the physics of it. So this was before doing the research. We just said, let's have gravel and the sculpture. This was for the Chicago Biennale in 2015. And we created this sculpture just by layers of 2 centimeters of gravel with one of these robotically printed string patterns in it. Here you see the demolding. You see the boundary condition now are removed. And once the boundary condition have gone, everything that is not jammed by the string collapses or can be brought to collapse. And we ended up with this strange object that is designed on the logic of the jamming principle. So we put as much load as possible on top of it in order to have the max pressure on these 4 slender legs in order to have them really jammed, and have this 1.5 ton of material hovering sort of in an exhibition space in the US, and there is no security, nothing, there is no steel inside, there is no, just what you see is what it is. Again, this very special materiality, irritating. The single parts are you can brush this, you can destroy it by brushing it, for example, but not by hitting it. It's extremely robust. If you hit it, it does nothing, because it just redistributes load. But I want to end on this last small movie. This was then the finissage at the end of the Biennale. Here we just pulled back the string that was deposited by the robot. And of course, it's an artistic installation. We don't have any idea how to use this material to build buildings, but it doesn't matter for now. What it's showing nicely is that, these material systems, can go beyond the building process itself, but also, incorporate the reuse aspect of them. Because here, through this recuperation of the string, you could say we run the movie back. We invert the movie, and we end up with a nice heap of material, basically with the condition we started with before introducing architectural intention and geometry in it through the robots and the computational design, plus a nice roll of string that could eventually be used to build the next piece. And this is a way we should start to seriously think about architecture. And now the question is, and this is also on probably the note on which I would like to end this talk. It's if we think of what architecture on one hand needs to become in the future, so where we need to go in terms of meeting the demands of urbanization, of economy, of the global population growing, not growing, doesn't matter, of sustainability, of climate change, all this things that, it's clear then we need to become more efficient, more intelligent with architecture. And there, what I now on our side start to ask ourselves is, if we think at all these actors, we will for sure remain the most important part of this equation. Humans, educated, curious, researching about phenomena, questioning things. And then we have a physical reality that we should include in our consideration always. This is what we say with digital materiality. Only the digital is not interesting, it's misleading. And then we start now to have companions. For us, it was this robot, but maybe in a few years it's a humanoid robot, or it's other forms of intelligence that are around us, that can be controlled by us, but maybe also they enter a dialogue with us because they are just better than we are doing certain things. Imagine for us the robot laying the bricks. It was the first moment when we realized there is no reason to compete with this robot laying the bricks in this way. If we lay it in a normal way, we don't need a robot, but if you want to lay it this way, the robot is just better than we are. Is this a problem for us? No, as long as we can instrumentalize the process. And if we think now of artificial intelligence, of large language model, we are exactly at the same place. We could panic and say, this is a threat to us. Fine, might be. Or we could say, no, where is this mechanism, this tool, or this whatever, we want to define it better than we are. Once we have identified the place where the machine is better, and I would argue that now with these systems, drawing a floor plan, for a typology, architectural typology that exists, the machine is already better than we can ever be. Maybe it doesn't have the initial intuition we have, but just in iterating through all the possibilities, in knowing all the precedents, the historic precedents that we know because we read books and so on, but we can not know as much details as the machine does, So why compete with the machine on these things? We should start to collaborate with the machine. But again, without giving up our agency, because the machine, and this is very important, all these models are magic, but they don't have any human understanding of the world. They don't have empathy. They don't have, also at the level of, they can look at, gigantic amount of data that we cannot consider, but at a level of understanding for the real world, we still move ourselves in the world. We have a lot of sensors, that machines do not have, and we should be aware that in a potential collaboration, this is a key factor. There is this book, maybe as a last statement, by, and I looked at it recently again, by Georg Vrachliotis. Georg Vrachliotis is the dean of the Faculty of Architecture in Delft. He did a PhD here at ETH about 2010. That ended up in a book, small, very beautiful book. I think in English it's The Digital Condition, it's called, where he draws up the history, the long, short history of these things. Really, looking at what these people said and how this relationship between the human and the machine was understood. And there, in a chapter when he talks about Nicolas Negroponte and the architectural machine group, he says that probably Nicolas Negroponte was one of the first and only that really, understood that this machine that back then was a joke. you know, the machines these people had in the 60s. They were gigantic, doing almost nothing. So a lot was imagination, that projection of their visions into these technical tools. But he was talking about the robot as a partner. You know, that the robot, no, sorry, not the robot, the computer, that the computer would only become really interesting to architecture when you could start, you know, enter a dialogue with the computer, and when the computer would start to learn from you, you know, the same way another human would learn. And this was a completely different vision from, you know, from others. If you think of, you know, Gropius, for example, all these people were fascinated in the 60s by computers. But Gropius, for example, said, okay, we have architects, then we have machines. The machines can do cool stuff. And then we need programmers, because we architects cannot, you know, understand, we cannot program. So we need people that do the stuff for us. We need assistants, you know. So the assistant for Gropius is not a computer itself, but it's another human who is able to program the robot, the thing, you know. And from their perspective, I can imagine that this was made a lot of sense. You know, think of these big machines who need punch cards to do them banal stuff. But now we can talk with, you know, large language models, and the large language module create software for us. We don't even need to program, you know. We need to be able to understand what we're looking for, you know. So we are getting very close to this vision of a machine, an architectural machine, a computer that has a certain understanding of the problem and of the world, that enters a dialogue with the designing architect, human architect. You know, and maybe we can take, you know, it over again from there. Yeah. Okay, I think I unshare here. I think this is, yeah, this is probably the lecture, but also already a bit of the seminar.
Yes. Yes, exactly. Thank you very much for this very interesting talk and lecture. And I've tried to search for the book that you mentioned before, and I copied it in the chat. I don't know if it's correct, the one, The New Technological Condition. It seems interesting to read it.
Where is the chat? Yeah, chat. Yeah.
Up.
Oh. Yeah, it's this one. It's a short, very beautiful book. I recommend it.
Yeah.
I just found it at home. You know, again, when Georg wrote this book, there was no, you know, nobody was talking about artificial intelligence. There was no large language models, you know. But it's you know, if you read it now, 15 years later, you know, it's very interesting because it resonates on discussions we're having right now, and that are super actual. Yeah.
Great, thank you. So I have a lot of questions, but I don't know if before starting with question, I just want to say that now we start our debate with all the PhD students that are here and the researchers. And I don't know if I see now Professor Giovanni Durbiano, that he's the chair of this course, and earlier he wasn't arrived yet. I don't know if Giovanni, you want to start? Then we can hear you.
No, thanks, Federica. You can start. Vrakhaliotis was a professor, but was also the reviewer of another PhD thesis of Francesca Moro, that is one of the organizers that is here. So, I mean, we know him for that. Just a few combination, but no, it's not a combination. I mean, we try to grab the most interesting people that are working in it. Vrakhaliotis will be the reviewer of a PhD thesis of a colleague of Federica.
Yeah, he's. I mean, there are not so many people in history and theory that really, have this precision in understanding and describing, also in a certain perspective, what's. So it's logic that that it's part of the group.
Our objective is to build a network, international network, and to try to be able to enter in this network, trying to studying and to host occasion like this one.
Yeah.
Please, Federica.
Okay, so I will start, but everyone who has any question, please go on, and you can raise your hand or just talk. So I have maybe one first question is something that we didn't really touch in this lesson. So just to also open the pedagogical argument, are you, with all of this technological innovation, also the way of teaching to students is changing? So what kind of strategies have your department, and you're also with the foundation of the robotic lab, have you put it in practice to teach students to deal with the new technological transition, and maybe now with also artificial intelligence? Do you have some kind of strategy or something else?
Yes, we have, but this is not directly related now to our research, because our research, by the nature of it, particularly in the last 20 years, has been postgrad, PhD driven. So these are not labs that you can open up to bachelor, master students. Not large numbers of students can profit. And this is probably also the reason why, until not so long ago, to be self-critical, we have neglected basic education here at ETH on these topics. So the fact that we did the research from an architectural perspective probably has been very positive also for the discussion here and elsewhere, because what we the main claim of our work has been that this research needs to be done by architects from an architectural point of view. So it's not optimization engineering at the service of design, but it's part of the design research, or it's a design research itself. So to contextualize this has been useful, but practically we didn't have until probably 3, 4, 5, 6 a year ago, in bachelor at least, not really foundational classes on how to program, how to think about computation in design. Now this is changing, has changed in the last 4 years, because we introduced computational design as a mandatory course in bachelor.
Okay.
And we decided to go very, very, straightforward, saying, okay, what is the literacy, the basic literacy, like being able to move a pen on a paper? It's to program. And the advantage now compared to 20 years ago is that you don't need to program with code anymore. We can code graphically, and this is very close to how we think as architects. So that these two domains have come closer. And the second thing that we do is we don't do, or we try to do, just abstract exercises that might be too abstract for architects. Or let's say there is a reason why architects study architecture and not mathematics or physics, and there we try to go very directly into architectural problems. Now, if we program something, we program a truss or a structural system or a building, parts of a building, a facade, something that they can relate and see as part of their profession, of their competence. And then I also understand when these tools give them more possibilities. Because if we use the tools to do stuff that we could also draw, then it's pointless. But it's not always so easy to anticipate if you have a problem. When does it really, become computational? And this is an experience that is important, and sometimes, also failing. They try to do something and then find out, okay, this was been a lot of work, but I could have done it, just, for example, you do something that you only need to do once, and it's feasible. Maybe it takes you 4 hours of construction drawings and so on, modeling. It's fine, But if you have to do it already 3 times and it takes 4 hours, then it's maybe good to know how to program it. For me, the banal example for students is always take a stair. A stair that is programmed is not nicer than a stair that is drawn. So there is no intrinsic advantage of computation. I can draw it, I can model it. But if it's a stair that maybe is a bit specific, and I have a design, and I know in the next 3, 4 weeks, 6 weeks, I need to draw the stair 200 times, then if I'm able to program, I have a big advantage. I've increased my, reach into, and this is just utilitarian. But if you have the agency as architect to say, I program it, then this is, already engaging you with, or bringing you in contact with, with these questions. And this is now, changing very rapidly, because when we started this, you had to program it in Grasshopper, or let's say visually. Now you can talk with a large language model and discuss about how, this thing is done best, and then try to patch it together. And very quickly, the programming will not be the point anymore, will be about the concept. So the thinking about what to do and why, that is the thing we have to learn and to teach to students, not the programming itself. And this is, this is evolving very, very, very rapidly now. So probably will, by definition, lag behind as schools, because we have, it's a slower thing. It's not like in an architectural office where you just move with technology. Here you have curriculum reforms. They take 5, 6 years. Once you have finished one, you start the next one. It's about jobs, positions, money, lecture, space, and so on. But another example is, for example, Midjourney. How do we teach students how to deal with artificial reference? It's a completely new concept. A reference, it has been, ignored, or let's say banned from architecture for a long time, the reference. I'm thinking a bit relating to what Mario Carpo theorizes. It says basically copying has been a technique, since ever, and suddenly, with the modernism, it has been banned. There is in art and architecture. So you are inventing everything all the time, although it's not true. You're copying, but you're not talking about it. Now we had 2 things. First, the availability of visual or whatever conceptual impressions has exploded. So Instagram, so students often, I don't know if it's probably it's with you, it's the same. They come and say in a design process, I've seen, this building and I like it. So and the question is, are you copying it? Are you learning from it? Are you transforming it? And this is a building that exists. But with Midjourney and these techniques, I thought it's a building that doesn't even exist, that you start to copy from. And there, I think, again, it's less about the technology because the technology is simple to use. It's more about understanding and, understanding how to use it and when to use it. That is demanding. At the same time, I'm convinced these are not things that you can teach in a theoretical class. You cannot read a book about these things. In design, we need to play with these things, and then be self-critical. Do it and discuss it. Doesn't matter if it's Mid-Journey, large language models, or robots building stuff. Yeah,
Fabio, we call it intellectual technology, but is a technology too. Is another kind of technology to understand how to work.
Yeah.
So the question that you pose is very interesting. Is a way to say, in our position, I don't know if you have read the statement that that is on the base on our seminar. Federica, you sent him
this one?
Yes, this
Yeah.
Yeah, I read it. Yeah.
Yes, the idea is that we are living in different technologies, and one technology is what one you show us, but also to understand is an intellectual technologies, and our work is to move inside to change the technologies, intellectual or physical technology, in the direction that we are interested to go. So it's different kind of technology.
Yeah.
This is the idea, is a kind of description of a practice of the architect that is not a metaphysical practice, but really physical, really materialistic. Production and exchange of description of codes, of traces in philosophical way, and that can go to understand something and to conceive something or to build something. But if we are able to describe our practice as a technology, probably we stop to separate the work of architects and the work of engineer, the work of a storyteller and the work of how do you say muratori?
Masons. Yeah.
Masons.
Yeah.
So the idea is that there is a philosophical approach, that an ontology of our work that could be useful to redefine the field of our work. Obviously, the AI is going to change everything, but the description of our work is not so different from the work of Palladio in terms of technology, I mean.
Yeah.
This is the idea.
Yeah. I think I fully subscribe on the fact that this divide between the technology and the rest is artificial, has been instrumental or ideological debates and so on. And at least for us, it has never been meaningful in any way. At the same time, I acknowledge that the question on how we relate to technology. If we say everything is technology, even the design is technology and it's connected to other technology. There is this network, and everything has already been here. It's a data set, or what you in your text call the archive. The thing, and you navigate in this thing. We still think that there is something truly human, and this might also be a technology, but it's not something that can be formalized easily, or maybe that shouldn't even be formalized, and maybe this is a bit dangerous because we have, like, you know, learned to be wrong. Last time with ChatGPT, I would be perfectly honest, I wasn't expecting it in this way so fast, you know. But I still believe that at least as an attitude, we should appreciate the fact that we are friends of all the systems, that we communicate, that we don't distinguish, you know, that I call it, you know, like a dialogue in between, you know, at the same eye level, with respect, with mutual respect, you know, but there is a difference, you know. And this difference, the better we are able to set up the dialogue, the more, let's say, productive it becomes. And it also takes us the fear to be substituted, because I think if we don't engage in an interaction where we, you know, have capacity that the machine does not have, you know, then we end up again being competitive, being scared, you know. And this is a fact right now. I mean, I cannot, this sounds a bit naive, maybe a bit romantic, you know. I probably 90% of the people out there fearing for their job for good reasons, you know, wouldn't subscribe this, because there is a, you know, this is very, but I think that the competition between humans and machine is not productive as a discourse, you know. It's not leading anywhere. Yeah.
I don't feel the fear to be substitute as an architect, but I feel the challenge as professor to start to redefine the work of the architects.
Yeah.
If I will be, I would be very excited to be a student of architecture, of PhD student of in this moment.
Yeah.
Because everything is changing. And for example, yesterday, the philosopher Maurizio Ferraris explained us that the difference between intelligence, natural intelligence, artificial intelligence is the volunty. I mean, it's very simple, but we have the volunty where the machine doesn't have volunty. And so you have to rethink all our knowledge or our competence in terms of volunteers, in terms of not of performative, for example. In my thesis, also in my PhD thesis, we have the performance of the book of a thesis very quickly, because I mean you can have a book written in perfect Italian in 10 minutes, but in less than 10 minutes. But when you have this performative, you can start to discuss, you can start to change and deconstruct all the things that are inside the book, let's say. And this is very easy also for architectural design thesis. It's very easy to do everything. And after you have to discuss and to change again, because you go further in what is the problem that the thesis could try to solve.
Yeah, I like this. I agree. This, you know, the terms of volunty, of agency. This is what makes us unique. It's also because the biggest failure of technology in architecture or in society have always been when people started to believe that we could, you know, program everything. For example, that we could find the rules governing aesthetics, you know, in order to describe them in a mathematical manner, you know. And this ended up mainly, you know, in disasters at the different scales, you know, because we were not acknowledging that, you know, our volunty to do something that is not rational, that is not, you know, the fastest way to the goal, that is not, cannot be anticipated, can create new solutions that are not in the data set, that are not in the archive yet, you know, by associations. Of course, you always you build up on what is already there, you know, but this evolutionary moment when something happens, you know, that is unexpected, this is what brings culture forward. But also, you know, and this is us. It's not, you know, LLMs and so on. They just structurally, they are not able to do this, you know.
I think that association and unexpected, that you do two words that you use now, are very important because probably if we as architects could have some competence in something that is between expected and unexpected. Because our job is to make promise, and the promise is always something that you don't control completely because your promise about future, you don't know future. So if there is something that is unpredictable, but a little bit predictable, not completely unpredictable, so you are a storyteller, how do you say, a writer, a romanziere. Otherwise, not completely predictable. Otherwise, you are an engineer, but you are able to manage a program very formally. If you are in the middle between predictable and unpredictable, and there is some association that is not, association of instances that have to be in part calculated and in part invented, probably this could be the domain of our work in the future. I know that is very abstract, but the two words that you use are very clear in these terms.
I fully subscribe this. Yeah. There is a question.
May I? Yeah. Okay.
Sure.
Can you hear me?
Yeah.
Okay. First of all, thank you very much. I'm actually quite fond of your work, and the presentation was astonishing. Because the Federica just asked about pedagogy, I was trying to connect to my question. So I was wondering, as we all know, when we start our career, we asked to make IELTS, architecture exams, and different language exams or skill exams. In fact, you said you're an architect, but at the end you came up with this great career. So do you think now in the schools they should ask new skills like data reading, programming, or at least digital project management? Because, for example, for my PhD thesis, which is traditional architecture, I'm making a language model for my thesis, which has not been asked, but I'm making because I like coding. So I was wondering, do you think these ages requires new languages rather than English, Italian, French, but more like a digital oriented?
Absolutely. This is also what we're doing. I was just going, one step further, saying that maybe in a few years the language, the syntax doesn't matter so much anymore, because there are AI tools that help you.
Yeah.
The same as, it's nice if you can speak French and English and so on, but you don't, at least the writing 5 years ago, you needed, to write French in the correct way is not so easy. Now I can use an English text or German text or so it becomes more diffuse. So this is why I think the really important thing we should teach and train is the understanding, intellectual understanding. And there I say it's like in design, you can only learn this when designing. It's like design. I cannot explain you in a lecture what design is. I can show you 1,000 lectures, and you can read 1,000 books, but you will understand what design means when designing. And this is why in schools of architecture we have, ateliers, and we do projects and we discuss projects. This is the reason. And the same thing applies to these digital tools. So you have to use them. So we'll have to program. You have to do it wrong. But what I'm trying to say is at the end, to be a good programmer in C++ or Python or whatever is irrelevant, because these things change too fast. Once you finish your study, a new language is there. So what is really, essential? The understanding, what we were talking before, for the role and the potential and, these things. And then you will be able to manage these things in your professional lives. Doesn't matter, how things evolve.
Yeah.
So it's a yes and no. I would say yes. Let's do programming classes, but not focus on the excellence of the programming. Focus on the intellectual maturity of understanding what we are doing.
Okay.
And if I would do an exam at the end, I don't want to know if they know the syntax of the particular programming language, but I want to understand, did they understand how you know, our world works and how this relates to our job and you know, these things.
To understand, what was your milestone? Like, when did you start thinking out of the system of traditional way of thinking of architecture?
This was very early, but probably in a rather unconscious way. For us, it was because both me and Matthias, we learned to program in the 80s with this pre-user UI, you know, interface computers like the Commodore 64, this stuff. And these were toys, strange toys that only existed for about 5 years. They were cheap enough to be toys, but still expensive. And you could do nothing else than program. So it's like if you would learn French when you are 15, just because you are sent to Paris for a year. You just learn it, you know, and it's nothing super special. And then when we studied architecture in a very traditional context, we realized that independent one from each other. We just found out later that this was a common experience, that to design and to program were two intellectual activities that were related to each other. It's about organizing things, you know? And both are super abstract. If you organize a floor plan or a thing, or it's the same, you know, if you organize data. And the motivation then to go further and to start to explore the domain, let's say the place where these two realities meet with you know, the robot first, or this table. You know, why did we do this table? Because we are very interested to find out when do these things meet each other, you know.
Cool. And if
so it was probably out of frustration, because and also observing that these two, you know, worlds did not communicate to each other in any way. They were scared of each other in the 90s, you know. Now nobody would seriously argue that technology, you know, is an enemy of architecture. No. But if you look at, you can find this stuff, you know, online. If you look at interview of very good, very important, very intelligent architecture, probably mid-90s, they were telling that nobody would ever use a CAD system because it's useless. And yes, it's useless, but it's useless because the whole generation before us didn't really think about what it means, you know.
Now maybe it's the same with artificial intelligence.
Yeah, the risk is that we do the same mistake again. But I think we have learned something, so that just ignoring the snake, you know, is not really helping you. Because all these people that were truly convinced that this technology would not affect their profession, 5 years later had the office full of computers, young people using computers, not to do better architecture, but just to do it faster. Not because they decided to, but because the client obliged them to do, because he was not paying anymore, you know, all the draft people that would do all this thing manually, you know. So it's tragic, but it's how it went. I'm not generalizing to everybody, but this is the profession, you know, at large, basically. And now, yeah, true. Same could happen with artificial intelligence, that in 5 years we find out, okay, we have been, you know, Google has a few technical bots that are just better, you know, and our clients we used to have oblige us to use them, you know, to deliver better, you know, pre-projects on stuff, because it's because they want to only pay 1/10 of what they pay now for it, you know. And then we will complain because we haven't been anticipating this thing. We haven't been, you know, participating on the development of these tools. So why is a CAD system so stupid as it is, architecturally speaking? Because it hasn't been developed by architects for architects, you know, but maybe by some, you know, other industry, aerospace or movie, animation industry.
And if we have time, can I ask one more question, if it's okay?
I have time. Maybe you have to.
Okay. No, I about your Chicago Biennale Gravel project. So at the end, the design was not designed, right? Because at the end, what came up was like came up by making. Am
Which
I
one
correct?
do you mean?
The gravel project in the Chicago Biennale.
No, that's not true. We never design something that comes up automatically.
Okay.
There is always a lot of agency and this idiosyncrasy. What I'm saying is that in order to drive the design or to inform the design, we look at the material and the process.
Okay.
So
But
it's
the
not
final,
disconnected. But at
but
the
the
end,
final
how
shape,
it sorry?
but the final shape was came up by calculations or
No. I mean the informing moment is how do I put as much material
okay,
high
okay,
up
okay,
in
okay.
order to have the maximum. So the
Okay.
ratio between these four legs that are maybe 15 centimeters in diameters and this ton of gravel hovering on top, this is governed, this decided, if you want, by the material system, but the way we put it in scene, and decide to give it form, this is a design process.
Okay. Thank you.
I wanted to connect it to this project because earlier you were saying that usually your process of designing new things is that you start with an exhibition, and then if it works, to experiment things, and then if it works, you apply for grants to and then study the physics of the system and maybe go deeper in the system. So I was very curious on like how does your projects work? Like, is this a method that you usually follow? Who are your clients in the research lab? With who do you collaborate? I think with also industries, or I don't know.
Yeah, it's just a pattern that we observe. I don't know how. It's not, strategic. We don't follow it strategically all the time, but we observed that, we started our research with teaching. At the very beginning, we were doing research with students, master students, small groups. And then at a certain point, we professionalized this. And the reason was with master students, because this is what we had at hand. PhD student costs money. So you need to write a grant. Of course, then you have more commitment, longer. But, at a certain point, then we started to move towards this. And we have done research project that pretty, in a more or less classical way, started from a problem, and then we described the problem when we got money and we hired students, PhD students. But sometimes, because as architects, we still work in a domain that is not purely scientific. So if you get invited as architect to, let's say, Chicago Biennale, basically what they want is a cool installation, and this is an opportunity to do something that, a scientific grant would never approve because you don't have any evidence for it. You could describe and they would laugh, the experts. And there you have the freedom to test something, and eventually, we have done many things that didn't lead anywhere. But once you have found a mechanism and you have a proof of concept and you have financed it, because this kind of work have a very limited, very, very small budget, but a lot of energy, because the visibility and so there too you can engage students, to for example, now with this gravel thing, the student that then later on did the PhD on it for 4 years was a master student that we were, able to bring into the project, and then enthusiastically develop this Chicago Biennale sculpture. Let's call it sculpture with us, And then he started to write a grant together with us, but with the credibility of the person that was describing something he was passionate about and that he already tried out. and then he got the grant. Or let's say we got the grant, but he, was financed for 4 years and wrote his dissertation on, this is the mechanism. But it's not it doesn't work always. You have, also the things that fail and that don't lead to a, a thing that you can do research.
And what happens after, like, your research? Because you do a lot of projects that could be then transformed into workflows that maybe can be applied to a lot of construction sites or reused by maybe other firms or other companies. Do this happen, or do they remain your experiments? I don't know if the question was clear.
Yeah, this is very, very heterogeneous. Some are directly applicable because they are, just hitting, but even in industry, not just in, as a hypothesis of a process, and some other are, I would call them fundamental research, things that maybe, in 5 or 10 years with different, technological, economical boundary conditions will maybe become relevant. Maybe somebody will discover them, look back and say, okay, this now back then was just a nice idea, but not mature enough to be, we did 2011 nice work, installation work, even a PhD with drones. Drones building with ropes, flying and knitting in the air, and we did a PhD on this. Very nice work, but we stopped it because it became clear the next step would be to go outside the lab, and there was not, and still there is no technology, positioning technology that is precise enough or that is comparable. We could do it with motion capture, which is a lab technology, high speed, photographs. But outside of the lab with wind and GPS and so on, it was far away. But maybe in 2 or 10 or 50 years, I don't know. It's hard to, things can go so fast or so long. This will be, this research can be continued by us, or depending when, by somebody else. It doesn't, I think research, it's about this. Some things are very pragmatic, or turn out to be very pragmatic and applicable, can turn into, we have a few startups, that were then, taken on by students, and some other things are just nice projects, end up in a nice dissertation in whatever, and eventually will never be used again. It's fine, if you would know in advance where things end, we wouldn't do research anymore.
Of course. Elisa.
Hi, do you listen me? Do you hear me? Okay.
Yeah.
Firstly, thank you for your presentation. It was very interesting. All the topics very amazing. I was very I find very interesting the mostly the shooting builder. I find it quite curious, and also mostly the approach near it. So the firstly we try, and then if it works and leads to something that can go much deeper or beyond, we can focus on physics and development. I think that this approach can lead to innovation through, kind of serendipity approach, like a curiosity lead, and find it very interesting. And talk about later we talk about the art exposition, the artworks, but my question also works for the architectural experiment in order to replicate them in a bigger cases. I would like to ask you, you talk about collaboration, so using these technologies and these methodologies, not just like tools itself, but like in collaboration with, and maybe it's a little provocative, but I want to ask you if you consider this technology like the machine itself, or eventually the computer generative app, if we talk about generative design, just for the project phases, like co-author. Like, I don't know if I made myself clear about.
I would say, of course, yeah. So that we're all these things are part of an ecosystem where I would even, if I would be a craft person 3 centuries ago or in the Middle Ages, and I'm, working with metal, and I have tools that are given to me by, I don't know, my family or from my master, and I learn how to use them and to improve them, in order to give them to my kids. And this is how, technology has evolved in history, until Industrial Revolution and so on. I would even consider these non-alive or tools as co-authors in some sense, in the sense that without them and without all the knowledge and the culture they incorporate, they stand for, I would be just pretty useless with my imagination and my, hands, without tools. So now these very sophisticated tools we are talking about, are also, engaged in a more complex way with us than just being inanimate things that we can use or not use, because we need all this experience and training, to interact with them. So I would say yes, of course. Then, what I'm also sure is that in this co-authorship relationship, there is, how do you call it? Not a hierarchy, but there is a rule set. So it's not, you're not exchangeable, but the fact that you cannot, you depend on each other. It's like this person sitting on the robot. This image, they belong together, and they don't dominate each other, they don't threaten each other, but they depend on each other. It's an ecosystem. If we don't have the tools, then we have a problem. The tools without us driving them also, maybe they don't care, the tools, but still, it's a, and this is, it's a positive relation of dependency. And this, in a generous way, can be defined as co-authorship.
Yeah, and I think in this environment, it's become more clear the important to understand how these tools and mechanism works, just to find the best way to bring up the best of this relation, just not to be in just like lead by these tools, but just to control them and of course help them to evolve in a
there are indeed a lot of parallels to craft. So the notion that the tool is a thing that is in constant evolution, and the evolution is not driven only by some, somebody else outside, but most of the improvement to the tool come from the craft person itself. I think in before modern industrial era, there were no people thinking about better tools. The only people thinking about how to do better tools were the people using them. This was also the social organizational model. How this knowledge was kept in place and transmitted, and it was a very complex thing. Now, of course, with specialization, this has become a bit more complex. But I would say that still, think of medical instruments, for example. Of course, there are big corporations that think about new tools for, doctors, and it's a gigantic market. But at the end, understanding how these people use it and the feedback, is crucial. Nobody could do this, without an understanding for the craft, and even though, but it's not true. I mean, the most amazing big steps in surgery, for example, the inventions or the people behind the certain tools and company, these were surgeons, that suddenly understood that if they would change their tools a bit, they would be able to do or the whole robotics, the people behind this are not just roboticists. These are people that know how a certain intervention, where it could profit from a robotic hand, and it's not about just increasing the productivity. It's about making things that were not possible before, certain operations. It's not about being a good or bad surgeon, just not possible because of the scale, for example, or non-invasive, invasive surgery. It's a nice concept, but you need to turn it in reality. And there, I think this understanding for the tool is not an abstract one. So it's not a thing that we can teach to ourselves or to the students just by talking about it, but they need to practice it. It's like if we would just talk in architectural school, just talking about design, this would never produce usable architects. It's hopeless. And this is what craft is about. So this, I would say, if you use LLM, if you use them to program, if you use them to write text, if you use Midjourney to produce images, the only way to become knowledgeable and good at their use is to use them. Producing many, bad things on the way.
Of course,
what is
yes.
not the problem, as long as you critically, recognize it and discuss it. This is then again the school, the role of the group of the school is to contextualize these things, and to reflect on what comes out of these things. But if you say, no, don't use it, because it's not good, or if you say it, I explain you in theory how these things works, this is both, not meaningful in terms of didactics, sort of.
Thank you for your answer.
You're welcome.
Thank you very much. I don't know if there are other questions. If there are no more questions, I think we can close our seminar. And really, thank you very much for your very interesting lesson and for all the debate that was after the lesson. And we learned a lot of things, and it was very useful for our.
But Fabio knows that we will ask him to leave something of a text of this lecture, that we would like to make a little book about with a collection of of the test of our guest, if you agree, obviously.
Yeah, I've read this somewhere. I mean, I'm open. Question is which text and where does it come from and how do we edit it? But you recorded this right now.
Yes.
Yeah, we recorded.
But let's say I
it
don't
and-
have a text on what we just discussed. Let's say it's a topic we're still developing, and for me this discussion is as instructive as it is for you. So normally by debating things you understand them
Yes.
better. So I cannot send you a text with the thoughts we just discussed.
No,
but,
we have some experiences and some ideas that are coming out from experiences, and we are sharing. And so this is why we thought this is intellectual technologies. I mean,
yeah,
it's something that is growing in this moment. The idea is to understand how it's possible to describe the new challenges of the work for architects.
yeah.
Okay.
No, I'm absolutely interested in.
Thank you very much. And nice
You're
to meet
welcome.
you.
Okay. Have a nice weekend.
Bye bye.
Thank you. You too.
Bye-bye.
and,
Thank you very
Bye-bye.
Hope to
Bye-bye.
see you soon.
Thank you.
Yeah.
Ciao.
Bye. Bye-bye.
Thank you.
Ciao, ciao.